Specification-driven development. It's everywhere these days, and it seems like there are dozens of tools that use the term. But the fact is, most don't actually deliver on what the name promises. In this video, I want to go through what that actually is and where the current crop of tools falls short, and then what you can do to actually do specification-driven development well. Because it comes down to a single distinction, and everything follows from that. A specification can be either a document that AI promises to follow or a test that it absolutely has to pass. I ran into this myself the other day when I was building a sample project. I wanted to build a cashback service API, and the requirements were pretty simple. I wanted customers to earn cashbacks, but only on eligible purchases. So I got the API to implement it, and it writes some code, it writes a few tests, and it comes back to me and it tells me it's all good, it's all done, everything passes. And I almost take its word for it, but then I read the code, and turns out it's paying cash back on refunds as well. So from the point of view of AI, it hadn't lied to me. It had checked its code against its own understanding of the specs and written tests that confirmed this understanding. Nothing independent ever contradicted it, so nothing ever went red. Now, this was only a sample project, so it cost me a few hours, not a big deal, but in a real code base, then that's a production incident. Pharos actually tracked 22,000 developers across a 2-year period, and what they found was that once AI adoption is high, the odds of an incident for every pull request more than tripled. Because the real problem wasn't AI's inability to code. It was nothing independent ever proved that the code did what it was actually meant to do. And we're seeing this effect right across the industry. Pharos did a study across 22,000 developers and 4,000 teams, and they called the phenomenon the Acceleration Whiplash. And what it basically means is that throughput does go up. The tasks per developer increases. You can get through more epics. You can get through code-specific jobs much faster. The code gets generated much more quickly. But, and there's a big but, the same teams saw defects go up by 54%. And I've seen these figures even higher in other studies. The number of production incidents per pull request more than tripled. And what the report basically says is that it's not a question of putting more reviews or more QA into the process, because the code is kind of rubbish to start with. The real fix needs to happen when the code gets written, using smaller changes, faster feedback, and something that proves that every step is correct as you go along. So what's the answer? Well, a lot of people are saying specification-driven development. But the thing is, there's a lot of interpretations of what that actually means, and a lot of different tools do it slightly differently. So we need to understand what all the variations are before we can decide whether that is really the solution and whether that will work for our projects. The basic idea of specification-driven development is that you write down a specification document of some kind before you write the code, and that specification document is your source of truth. But where people part company is what that specification actually is. And this general approach has been around for a while. If you look at APIs, you can think of an open API schema where you generate stubs and clients from an open API standard as a form of specification-driven development. And there's also formal methods which aren't very widely used in the broader industry, but try to prove mathematically that your code does what it's supposed to do. And there are a whole bunch of new AI-driven tools like Kiro or GitHub Spec Kit, which treat specifications as markdown blueprints that are going to guide your AI agent through planning and implementing a feature. And then on the other end of the scale, we have BDD, or specification-driven development, where rules and examples are expressed in the form of tests, and these tests become your executable specifications. So the question is, which of these can we actually rely on? The idea of specification-driven development sometimes makes a lot of experienced developers wince a little bit because it sounds like you're designing everything up front. And we know how that goes. You spend weeks writing the perfect specification, then weeks planning it, then weeks building it, and around week 13 you figure out that the specification you wrote was actually wrong. And you end up building a system that nobody actually wanted. And to be fair, there are good reasons to be wary. ThoughtWorks said that specification-driven development carries a heavy bias towards big upfront specifications and big bang-style releases. And Martin Fowler, looking at tools like Kiro and SpecKit, said that for most real-world work, they're like using a sledgehammer to crack a walnut. So the risks are real, but the question was never whether to specify or not. The real question is how long it takes between when you specify something and when you get confirmation that what you built is what you wanted to build. The first trick is something we've known for a very long time. Small batches of work better than big batches to get stuff done. Instead of one enormous specification document, you specify it little by little, learn, and then continue on your way. And AI allows us to accelerate things without losing control. You take one feature, you identify the business rules and the examples and counterexamples that will illustrate that business rule and clarify your understanding. You turn those examples into acceptance criteria, automated acceptance tests that will fail because the feature doesn't work. Then you get your AI agent to write the minimum amount of code to make those acceptance criteria pass. Then, with the help of AI, once again, you review the new code. Does it do what the specifications ask for? Are there any missing edge cases? Are there any security vulnerabilities? Is there any duplicated code that could be refactored into the main body? And so forth. And if this sounds a lot like TDD or test-driven development, that's because it basically is. But you're getting AI to do the hard, boring stuff, and you're staying in control of the requirements and the thinking. But the key thing with this process is that at the end of implementing a feature, at the end of implementing a batch of features, you have a set of executable specifications that reliably say whether your application runs. And AI makes these executable specifications much faster and much more reliable to create. Because that's the crux of the matter. All of the SDD tools promise the idea of executable specifications, but the trouble is that executable means very different things. In most cases, then what we call an executable specification is actually a recommendation, a guideline. The system shall do this, the system shall do that. The agent writes code based on those executable specifications, but there's no guarantee that it will actually implement that correctly or analyze all of the edge cases and the variations and the underlying assumptions that went into that code and make sure they are correct. But when your specifications become executable, AI has a lot more trouble misinterpreting. It can't cheat. The test will fail until your code does what you expect it to do. And this is the approach I found works really well with AI. We use AI at all levels of the process, but we use AI to help us shorten the feedback cycles, not prompt and pray. We start off with the discovery phase, where we work on a particular feature and we use techniques like example mapping to discover the rules and examples and to come up with ideas about what sort of edge cases and what sort of error conditions we might need to handle. And the beautiful thing here is we can use AI to streamline and accelerate this process, but we're still using a collaborative technique. We're working with business folk, with team members to make sure we have got all our bases covered. And this alone is hugely valuable. This is a game changer in terms of team collaboration and the quality of the results that you get. But once you've identified your acceptance criteria, your rules and your examples for the feature that you want to build, you need to actually turn those rules and examples into an executable format. And again, AI can streamline this process very effectively. And this is where we use a BDD or an ATD approach to automate our acceptance criteria and drive development from the outside in. And at each stage, we're using our AI agent to streamline the process as a partner, not as a tool. We use AI to bounce ideas around about our requirements, about our examples and rules, to scaffold test automation more quickly, to drive the automation and the implementation as we go down into the code, and to review the results. And all the time using this underlying principle that we're not done until our automated acceptance tests that represent our actual requirements are green. How this will work with your project will depend, obviously, on your technology stack and on the AI tools you're using. What I've done with Claude, for example, is define a set of skills and commands that allow me to automate each stage of the process. We take a user story, we run discover against that user story, and we come up with a set of rules and examples and questions as well about ambiguities in the requirements. We use the accept command or skill to turn these requirements into automated acceptance tests. And obviously they fail because the feature has not been implemented. Then we go into a TDD phase where one rule at a time, one acceptance criteria at a time, we make those acceptance criteria pass. Once everything is done and our feature has all of its acceptance criteria working, we run a review phase, sometimes several times, to look for inconsistencies, to look for errors, to look for things that it may have missed earlier on. And then we can apply what we've learned to the next story. So you might be thinking this sounds a lot like behavior-driven development, and it kind of is. We're not using given, when, then in this particular case. You could if you wanted to, but the general concept is very similar. We are turning requirements into executable specifications that drive our development. But why is it easier now with AI than it was previously? Well, previously, the step where you generate your executable specifications, then turn them into automated code, was rather laborious, and a lot of teams struggle to do that well. But with AI, we can streamline that and go a lot faster. We can get those executable specifications written and automated very quickly and get a really fast turnaround. And this is where we see huge benefits. It takes a lot of the time out of all of those laborious tasks and lets you focus on identifying, understanding, and delivering useful requirements. It doesn't replace thinking, but it makes writing specifications and automating them cheap enough to be really worthwhile. So if you take one thing away from this little video, this is it. Most specification-driven development specs are a document that AI promises to follow. It may or may not keep that promise. An executable specification, on the other hand, is a test that it must pass. And in practical terms, this distinction is important, and it comes down to 4 core habits that work with pretty much any tool. You want to specify in small cycles, minutes rather than months. Make the specifications executable, automated tests, not markdown prose. You want to keep it alive, refine it with each cycle, and let AI do the translation from spec to test, which is the part that used to take so much time. Now, if you are curious about how this approach works in more detail and want to see step by step how we implement this solution for different types of projects, I've prepared a little course. You can find the link further down. It's about how to use this approach with Claude Code, focusing on Java and Spring Boot, but the approach works for pretty much any tech stack. So have a look at that if you do want to learn more. But either way, stop writing specs that AI treats as just promises and start writing ones that actually have to pass.